Hey, how you doing? Ketsu. Yeah, me again. Just give you a good shot of the circuit diagram. I'm going to show you why this circuit, this is the base circuit here, why it has nothing to do with the output here. Current of the output goes this way and this way. Current of the input, right before the transistor shuts off, goes this way. So this is negative when you put power out, but it's positive here, the power source. And at the point where it puts out power, the transistor shuts down, it's off. There's no power coming from the source. And this, in a way, explains why you can have more current out, 300 milliamp, than current in, 100 milliamp. Because we're taking power. Oh, that's a terrible picture. From this core here. We're taking power from this core. The transistor totally shuts down during the cycle, and we get this current out. Let me try to show you. Basically, I've showed it before, but I'll show you again. The lighting is terrible, of course. Not a movie maker. Oops, not again. Better just hold it up. Show you the input current. And output current. I need a bigger workroom. Output current. There. The coil. Leads here. One lead into that meter. It's on the 10 amp scale. Almost shorted out. 100% current going right into the meter. Crappy picture. And the power supply is here. Better lighting. Here. 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 Back. Oh man, there's wires just everywhere. Input current. This meter. Now, this resistor. I'm trying to go as fast as I can, but I want to explain it well. This resistor here, 5K. Variable resistor on the base circuit here. Now, to find that sweet spot, you have to have more current out than you have in. That's what I've done right here. Now, watch what happens when I try to draw more power from that transformer I showed you. I'm turning down the resistance. See, we're drawing more current now. Drawing more current, drawing more current. Uh-oh, look. Now the transistor's drawing more current. That guy. But look at our output current. It's less. We have less power out now than input. That's a bad spot. What we're doing here is putting more power into this wheel than we're taking out and into this transformer. It's starting to shake now. Can you hear that? It's turning up faster. So we're powering the wheel more, and we're not getting any harvest power. We're getting some, but not enough. So I'm going to turn the resistor higher resistance. So the input current goes down. And guess what? When you draw less current to the system, you get more out. 400 milliamp out, 180 milliamp in. Let's go to, let's do a higher resistance, drop that current down even more. 80 milliamp in, 70, 80, something like that. Output 260 milliamp. And that happens because these two systems are separate. Because this becomes negative at the point where this transistor shuts down during the pulse phase. And all the power is collapsed on this core and you get power out. Well, if this is always negative, you can't be drawing from the source, which is positive. This point switches from positive to negative. And the reason I say this so much is because I want you to understand the output goes this way and has a similarity, but it's not completely the same as the normal run current, which goes this way in the opposite direction. When the transistor turns on, current goes this way. When the transistor shuts off during the phase, current goes this way. And when they become unrelated, which is what Bedini was trying to do, when the two become unrelated, you can achieve a power gain and overunity. That's all for now. Maybe I'll make another video in a little while. I'll talk with everybody later.